Welcome to today's webinar. I'm Brian Landerman, Director of Enterprise Strategy at AWS, and we're a team of former CTOs and CIOs that led large-scale migrations of our company's infrastructure to AWS. Prior to joining AWS earlier this year, I was a CTO at Cox Automotive. Today, we'll talk about modern applications and how AWS is helping customers transition to this new way of building software. Today, we'll cover an overview of what we mean when we say modern applications, and then zoom out to look at trends we're seeing in enterprise businesses. Then we'll deep dive on what Amazon has done to transform over the past several years, and talk about what you can do to begin building modern applications. We'll then wrap up with some of the benefits of modern apps. Before we dive in, it's important to level set on what we mean by modern applications. The good, or perhaps bad news, is that modern app practices and modern applications refer to a point-in-time perspective. What we're going to cover is based on what modern means today. In summary, it's about how builders are leveraging people, process, and technology to build automated, operatable, business-focused solutions. A modern approach to software development is centered around shrinking the scope by leveraging different techniques to prove or disprove hypotheses quickly, in a fast and safe way, in search of customer value, and offloading the undifferentiated pieces by seeking out ways to do less in order to do more, and choosing the right tool for the job to create more purpose-built solutions with less effort, and automating everything for speed, consistency, and safety. Now let's step back and look at trends we're seeing with enterprise customers. My team speaks to over 1,000 customers each year, and we see consistent themes regardless of size or industry. We like to talk about these key themes in terms of a frequency spectrum. On the left, you have a low-frequency enterprise where no change is the default state. Change is hard, risky, and takes a lot of time and effort. Versus the right side where change is constant. There's a flywheel of frequent value delivery. Ideas are considered hypotheses, and teams are closer to customers and generally more focused on customer value. According to McKinsey, 90% of CEOs believe their industry will be digitally disrupted, but only 15% feel well positioned to execute on a high-frequency digital strategy. Similarly, from Gartner, 67% of leaders believe they need to move to a higher frequency model to remain competitive. And on the flip side, we know that enterprises that have implemented high-frequency practices deliver value 46 times more frequently than traditional low-frequency enterprises. There are typically a few historical reasons or experiences that have led enterprises to operate in a low-frequency environment. Sometimes it's because of failing or unstable applications that force IT teams to spend more and more time just to keep them running. Or perhaps it's crisis or security compromise that has led the enterprise to become more cautious about making any changes for fear of creating a new exposure. Or perhaps it was a big bet launch failure due to missed deadlines, budget overruns, and unrealized expectations, which ultimately diminish confidence in the organization's ability to deliver. And that said, there are 4 areas that we see enterprises consistently focusing and iterating on to achieve escape velocity from their low-frequency environment. The first is breaking up the work, moving from monoliths to microservices. The second is investing in your workforce and putting them closer to your customers. The third is automating your bureaucracy to provide safety and speed. And the fourth is to build it in, don't bolt it on, assuming attack and failure. These 4 areas are very relevant to building modern applications, as the same techniques, practices, and technologies are required to achieve both high-frequency environments and to build modern applications. Let's look back at the history of Amazon. Back in 2001, Amazon had one monolithic application and one Oracle database. It took 11 hours to update. Now consider this in the context of the dot-com boom. We faced a serious challenge in time to market. So we had an idea. What if we increase the amount of ownership of each team, but decrease the scope of responsibility of teams? We called that concept the 2-pizza team because the team should be small enough that it can be fed by 2 pizzas, typically 5 to 10 people in size. Now, these teams were long-running and would own a specific set of functionality, and the teams were responsible for both developing and operating the service. These changes were rooted in the idea of figuring out what is most important to your business, your North Star, by thinking about where you want your business to be in 3 to 5 years. At Amazon, we knew time to market was our North Star, and so we made a people decision. And then we made some technology decisions to support this. More than a decade ago, Amazon took our monolithic code base and broke it apart into a service-oriented architecture. We refactored our single code base into small, focused, single-purpose services, which we call primitives. For example, we had a primitive for displaying the buy button on a product page, and we had one for calculating taxes. Every primitive was packaged as a standalone web service and had an HTTP interface. The business logic, and critically the data, were only exposed to other teams through hardened APIs. These building blocks only communicated to each other through the web service interfaces so other teams could take advantage of existing services. This created a highly decoupled architecture where these services could be iterated on independently as long as they adhered to their web service interface. To give you an idea of the scope of these small services, I've included this graphic on the right. This is the constellation of services that delivered the Amazon.com website back in 2009. And today, there are tens of thousands of these across Amazon. And we made a fundamental shift with our architecture in that there are no gatekeepers. There's no line to wait in for storage, compute, databases, or to start using machine learning. In the old world, when you asked engineering teams how long it would take to get a server to try an experiment, you get answers like 10 to 12 weeks. And with our North Star in mind, we set out to reinvent this experience to increase the rate at which we could experiment. We thought others would benefit from this as well, and in 2006, AWS was born. Now, in the cloud, you can provision thousands of servers within minutes, with 165 services that you can put together and use in whatever combination you want. You get from an idea to implementation in several orders of magnitude faster. This totally changes an organization, increasing the amount of cycles employees spend thinking about innovation because they know if they have an idea, they have a chance to see if it works. This expands the group of people inside a company that are thinking about new ideas from a select few to everyone. Instead of 11 hours of downtime to launch at Amazon.com, they now have over 60 million deployments a year. When we talk about two pizza teams and culture, remember that it has a practical application in the business. This is just Amazon's story, but thousands of customers have embarked on this journey as well, including Cox Automotive. To achieve this model of agility, let's look at what changes need to be made and how AWS has helped many of these customers with those changes. Let's start with architectural patterns. Choosing the right patterns can help you shrink the scope of work and create focus for your applications. APIs should be the front door of your microservice. By providing this hardened contract, we can create a well-defined boundary between service consumers and our data and business logic. Let's consider how we build new APIs at Amazon. The first thing anyone at Amazon does when they want to build a new API is check to see if the API already exists. If it does, great, we use it. If not, then the team writes up an API description to submit to our central API team. We call them API bar raisers. And if it passes muster, the team is allowed to go off and build it. Lots of our customers use this process as well. This creates a catalog of your microservices and provides an organized, transparent view of your microservices. Without it, you risk duplication of APIs, unauthoritative sources, and a lack of transparency into what exists. Next, let's look at the comparison of microservices to monoliths. With a monolith, you have a large single system that does everything. On the other hand, with microservices, the impact of change is smaller, so release velocity can increase. These smaller, finer-grained architectures do one thing, and do it well. And through componentization, we get small, easily identifiable pieces with well-defined interfaces. This allows us to create cohesive systems made up of many small parts working together. When we pair these finer-grained microservices with event-driven architectures, we can further simplify the components of the system. When you think about where or how to start building APIs, a question we often get, it typically makes sense to start by identifying events in your system, because events are a good indication of where your services can be interconnected and therefore decoupled. In the simplest terms, an event is a signal that a system state has changed. In most modern systems, these are represented as JSON messages that provide some set of facts about what changed and potentially what the current state of the system is. One of the key distinguishing features of events compared to commands is that events are observable, not directed. In a command model, each command is explicitly issued to a specific recipient. Events, on the other hand, are merely observable by other systems. So here, a customer just ordered a widget. One of his coworkers is adding it to the sales report. Another decides to send an invoice. And several others aren't even listening at all. What's nice about this is that it means that the event producer doesn't need to have any knowledge about who is listening to those events. This keeps them simple and allows other services to consume events without needing the upstream system to change. The benefit of event-driven architectures is that it allows you to shrink the scope of work by breaking it up into smaller pieces. This allows us to distribute the work while decreasing waste so we can focus on value. By no longer having to coordinate all the listeners and manage all the downstream tasks, systems become simpler and more focused. And as your architectural patterns change, your operational model needs to change as well. The goal is to offload the undifferentiated pieces so each team is more focused on delivering business value. The first question that often comes up is around complexity. Isn't it more complex to operate many tens or hundreds of services compared to a single monolith? Well, as a broad system, there's significantly more complexity. But if done right, for each service team, owning a small set of a larger system, it simplifies operations even though your larger system may be more complex. This is where services like AWS Cloud Map and AWS App Mesh become so important. They allow service owners to focus on their services while providing interfaces and visibility into the broader system. With the evolution of compute, there are options to further simplify your operations. Customers tell us containers are great, but managing the infrastructure is undifferentiated heavy lifting for them. Too much of their time is spent corralling infrastructure and not enough time is spent on the code, the application, and the application architecture, which is where they want to focus. Serverless lets you write code and lets somebody else worry about the infrastructure. Serverless removes the undifferentiated heavy lifting that is server operations, reducing your operational load. This allows you to focus on building applications and creating value for your customers rather than the management and scaling of the infrastructures to support the application. As you likely know, AWS has a shared responsibility model with customers where AWS is responsible for certain aspects of the infrastructure or system, and then there are parts that AWS customers must take responsibility for. AWS provides many options that allow you to choose the right amount of control and configurability. That said, as you move left to right, you can offload more and more of your responsibility to AWS. For example, by using the fully managed database DynamoDB, all you need to do is create tables, put data in those tables, and query the data. There's no infrastructure to manage, quality of service is built in, and there are a set of knobs and dials to configure the database to meet your system's needs. Another example is S3. We can create buckets and easily store files without having to worry about data durability or managing the data lifecycle. Simply configure your bucket and begin using it. In general, I recommend starting on the right and moving to the left only after proving you require more control. Because your goal should be to do less so you can do more. As you see on the right, all that a customer has to manage with AWS Lambda is application code. This means you can innovate more quickly and frequently and deliver value more often by doing less. From speaking to a lot of customers and having been a customer myself, there's a common question out there. What is more appropriate for my workload, AWS Lambda or AWS Fargate? And I wish the answer were more straightforward. However, I'd love to look at the differences between them. With Lambda, developers write code in units called functions and define a trigger to run the code. Lambda starts, stops, and scales automatically based on the usage load it receives and the scaling throughput parameters you define. You never have to worry about provisioning, scaling, patching, or managing the underlying servers, AWS takes care of it. Lambda is a great choice for applications that don't have specific infrastructure requirements. Because of its event-driven nature, AWS Lambda is great for data-driven applications that need to respond in real time to changes in data, shifts in system state, or actions by users for use cases such as batch processing, stream analytics, and machine learning inference. With AWS Fargate, you can run containers without having to manage servers or clusters. You no longer have to provision, configure, and scale clusters of virtual machines to run containers. This removes the need to choose server types, decide when to scale your clusters, or optimize cluster packing. AWS Fargate removes the need for you to interact with or think about servers or clusters and lets you focus on designing and building your applications. I'd recommend starting with Lambda and assessing whether or not it meets the needs of your workload. If not, AWS Fargate may be a better choice. Either way, serverless helps you offload as much undifferentiated heavy lifting to AWS as possible and is therefore my first choice. That said, it's still important to put your architecture hat on and explore your options to ensure you select the right tool for the job. Speaking of the right tool for the job, let's talk about how this new architecture impacts your database and data management. If you think about each of these ships as microservices and the mothership is their database, you can see how this common dependency, this monolithic database, could hold back the broader fleet. Or if we think about it in terms of Star Wars, think about how one good hit blew up the Death Star. There's a better way to design your microservices. If you design your microservices like we did at Amazon, where business logic and data management is hidden behind a hardened API, you can more easily change, manage, and scale your data and services independently. This also allows you to create more purpose-built solutions while spending less time fitting your data into, for example, a relational database when what you really need is a time series database. While we're not going to dive deep on AWS databases today, I wanted to quickly share the breadth of purpose-built databases that AWS offers beyond relational databases to allow you to select the right tool for the job. Now let's talk about how two-pizza teams and microservices change how you automate and how the cloud provides new opportunities for automation and guardrails. Let's start with the release process. In the old monolithic model, you might have something that looks like this. And this was certainly the case for Amazon, where we had a big team of developers stepping on each other as they made changes in a big monolithic app, having to batch up and coordinate testing and releasing, causing changes to be delayed to production and deployed slowly and infrequently. As you try to remove bottlenecks in this process and decompose for agility, you break up your big functional organization into smaller two-pizza teams. And as you introduce microservices owned by these teams, you've now removed bottlenecks in developing the solution, but not in testing and releasing it. In a product-based delivery environment, self-service tools and automation enable these DevOps teams to own and manage their own release process, creating ownership from idea to operation and back. I think you can see how teams would be able to move much more quickly in this type of environment compared to the first one. Now that you have smaller teams, focus on a smaller scope via microservices, we have a simplified environment. Through automation, we can build and automate security, making the development team a part of your security team. We can then provide security of the pipeline as well as security in the pipeline with things like artifact validation and static code analysis. And with open source tools like Cloud Custodian, we can provide built-in, constantly reinforcing guardrails that allow teams to move quickly while following the rules you define. When I hear guardrails, I always think of highways. And if you think about it, highways have defined speed limits, marked lanes, rules for passing, on-ramps and exits, and the curves in the road were designed to travel at higher speeds. With these rules, we're able to travel faster and move freely, at any time of day, on and off the highway as we see fit. Each car has autonomy in their movement and decision-making. But think about how frustrating toll booths are when you're cruising along at 65 miles per hour and you have to then slow down, stop, and wait in line to pay. Gates have a similar but often more disruptive effect on our software development process and flow. Modern applications have automated guardrails in place, allowing for the removal of gates. resulting in increased speed, autonomy, and agility. And while all of this may sound great, you may be asking yourself, how do I take my existing applications and turn them into modern applications? Let's explore the journey. Most customers don't start off migrating modern and mature cloud applications. We tend to migrate what we have and make improvements along the way to a truly optimized workload. And we eventually leverage serverless and fully managed services. We tend to start migrating what we have to EC2 or to a container service using AWS EKS, AWS ECS, or AWS Fargate. And while each is a good starting point, modernizing the architecture moves us up and to the right. And not surprisingly, AWS Lambda is in the top right because it helps us shrink the scope and take an event-driven approach while offloading operations to AWS. While we may prefer to flip a switch, the reality is that moving from monoliths to microservices is a journey, just like modernization and maturity. They don't happen overnight. The good news is that there are patterns used by many enterprises, including Cox Automotive, to simplify the transition. In 2004, Martin Fowler wrote about visiting Australia with his wife and spending some time in the rainforest on the Queensland coast. One of the natural wonders of the area are the huge strangler figs. They seed in the upper branches of a tree and gradually work their way down the tree until they root in the soil. Over many years, they grow into fantastic and beautiful shapes, meanwhile strangling and killing the tree that was their host. He went on to use this metaphor to define a pattern for slowly killing your old application that requires a rewrite. By intercepting events, as we discussed, and standing up APIs to replace the functionality responding to the event, you can remove functionality over time and eventually arrive at a place where the monolith no longer exists. It's a useful pattern. And it's one that Yelp used to break up their monolith. In 2011, Yelp had more than 1 million lines of code in a single monolithic repo called Yelp main. They decided to break up the monolith using a service-oriented architecture, and by 2014, they had more than 150 separate production services. They started with a 10-year-old revenue critical code that was dangerous to change, and a long-running process that was difficult to scale without impacting or changing the entire monolith. Where any single account failure blocked the entire workflow with limited visibility. It could take 24 hours to identify root cause. Still, using core methods from the monolith, Yelp lifted out the account billing process and put it in the middle of an AWS step functions workflow. This immediately gave them the benefits of acting like a service and gained an API interface they could manage. Instead of a huge refactor, they used AWS step functions to gradually and safely carve out one task at a time. They were able to reduce processing time and increase concurrency, and could easily scale up by submitting more workloads to run in parallel. And it works in hybrid architectures, whether running on premises or in containers, and enables monoliths to act like microservices. They said, we can now flexibly pick individual tasks and move them over to Lambda. And step function stays with us the whole way from monolith to serverless, helping us quickly build more efficient and resilient systems. I'd recommend looking into the strangler pattern and identifying events you can intercept to start your journey. Allow me to summarize what we've discussed. Customers are building modern applications by changing their people, process, and technology so they can innovate faster and more frequently and bring those innovations to market faster, all while reducing costs and building more reliable applications. We truly are witnessing a paradigm shift, and it's driven by our customers working backwards from what they need to do to win in the market. Businesses want to win more customers. To win more customers, they need to build better products and to release features faster, which requires faster and more frequent experimentation and innovation. And they need the ability to focus on differentiating business logic and to decouple software for speed and safety. We no longer live in a world with a single database or architectural option. AWS is providing ways for customers to shrink the scope, offload the undifferentiated pieces, choose the right tool for the job, and automate everything. And by doing so, you can build modern applications that allow you to win customers. Thank you so much for spending time with me today. Go build, and build modern. Cheers.